Knowing how to determine the x and y intercepts is going to help you on several fronts on the SAT. First, on occasion they do want to know what the x-intercept is or the y-intercept, but it's also a way of working with some of the functions, some of the graphs that they give you. Now remember, to determine the x and y-intercept, you have to think a little bit crossways. If you set x equal to 0 and y equal to 0, you'll find the x and y intercepts. But if you set x equal to 0, that gives you the y-intercept. That shows you where the x value is 0. That's where the line is going to cross the y-axis. Concomitantly, when you set y equal to 0, that shows you where the line is going to cross the x-axis. It's a little bit backwards, but once you realize it's that way, it's easy to remember. Now we're going to deal a little bit with abstractions. When we say abstractions, these are the type of problems where they give you variables or they give you something not concrete. In most cases, you're going to want to substitute numbers in order to make these things make sense. Let's look at an example. Let's say they give you a problem that says a drill bit is used by an oil company that will last for n feet. If each hole is q feet deep, how many drill bits are needed for x holes? Alright, there are no numbers here. And I don't know about you, but I don't like flipping around n and q and x. It's hard for me to keep track of it. So let's give these things value. Let's say that n, the number of feet a drill bit will last, is 100 feet. And let's say that each of these wells is q, or 300 feet deep. And we want to do 4 wells. Well, you just divide 300 feet by 100 feet to find out how many bits you're going to need, wouldn't you? And so you need 3 bits per hole. If I'm going to do 4 wells, that's 3 times 4. So now let's just substitute the letters back in for the numbers. Q goes where the 300 feet is. N goes where the 100 feet is. And you multiply that by x. So that's going to give us qx over n. Put numbers in there so you can make these things make sense. Now this strange looking thing is what we'll call a letter problem. In this case, they want to know the value of r. It looks unsolvable, but you have to realize there's a key to these, and the key lies to the left. We're used to adding from right to left, so you're going to start working and doing your work over there trying to solve for b. The key here is s. We want to know what s is, and s has to be a 1. Think about it. The two largest 3-digit numbers are 999 and 999. You add those together and you get 1,998. There's only one digit that s can represent, and it has to be a 1. Well, if it's a 1 in the thousands column, it's also a 1 in the tens column. That's the key to solving this problem. T represents a digit. Well, there are no 2 digits I can add together to give me a 1. So how did that 1 get there? It had to be carried from the ones column. So you have to carry that 1, and it has to come straight down, which means that T has to add up to something that ends in 0. So T has to be either 5 or 0. But since we have to add T to S to get a number greater than 10, that tells us T has to be 5. And now we can solve it. Because if T is 5, that means B has to be a 2. And if B is a 2 in the hundreds column, it's got to be a 2 in the ones column. What can I add to 4 to get something that gives me 12? 8. R has to be 8. When you start at the left side and work your way back logically, you can solve these problems. Remember, if you have a split numerator, that denominator applies to both the numbers in the numerator. In this case, if I've got r plus n over r, that separates to be r over r plus n over r. R over r is 1, so our solution to this would be 1 plus n over r. Remember, when you see a split numerator, and you'll see that a good bit on the SAT, remember when you see a split numerator, you have to apply the denominator to both the numbers in the numerator. The SAT has identified a peculiar thing that happens in the units digit. There's a repeating pattern here. in the units digit when you raise numbers to different powers. For instance, numbers that end in 2 go in a very set pattern. 2 to the 1 is 2, but 2 squared would be 4. 2 cubed would be 8. 2 to the 4th is 16. 2 to the 5th is 32. 2 to the 6th is 64. So you see there's a repeating pattern there of 4, 8, 6, 2. And that pattern repeats indefinitely. And 2 isn't the only one that has a pattern. Actually, all the digits do. 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 3 to the 5th is 243. So you can see that 3 goes 3, 9, 7, 1. That 2 repeats indefinitely. When you raise a number that ends in 3, you're going to see this pattern in the units digit. And as I said, a pattern applies to all the digits. 2 goes 2, 4, 8, 6. 3 is 3, 9, 7, 1. 4 repeats 4, 6, 4, 6. A number ending in 5 when raised to a power stays 5. Same thing with 6. A number with 6 in the units digit raised to powers is always going to have a 6 in the units digit. 7 goes 7, 9, 3, 1. 8 is 8, 4, 2, 6. 9 is either 9 or 1, 9, 1, 9, 1. Now you don't have to memorize these or anything, but just realize if they ask you a question about the units digit and any kind of pattern there, none of them goes more than 4 deep. I mean, you can identify the pattern by simply taking it to the 4 powers. The SAT is very fond of asking you questions about overlapping groups. The key to solving these is to get the numbers out of the words and account for the overlapping groups. In this case, there are 78 students taking math class. There are 102 students enrolled in science. 46 students take science and math. How many students are attending the 2 classes? The math is easy as long as you have the reasoning to back it up. First, we want the total in the classes. We've got 78 and 102, so there's 180 students enrolled in these 2 classes. But there are 46 that overlap or are in common. So we subtract that from the 180. We find out there are 134 students, actual students in the 2 classes. The SAT loves to give you fractions within fractions. If you have a fraction in the numerator, it's really pretty simple. It just drops down. In effect, if I've got 1/4 over 3, I'm just looking for 1/3 of 1/4, which is 1/12. They're much more likely to give you a fraction in the denominator. In this case, 3 divided by 1/4. Remember, when you have a fraction in the denominator, what you do is multiply the numerator by the reciprocal of the denominator. The reciprocal is what you would multiply that number by to get 1. In this case, the reciprocal of 1 over 4 would be 4 over 1. So we're multiplying 3 times 4 over 1, 12. They'll give you a pretty simple problem like this. At first glance, it looks easy, but you've got to remember there's a trick to it. You've got to remember to round up. Okay, in this case, if it takes 1 gallon to paint 8 square feet of wall, how many gallons are needed to paint 4 walls, each measuring 11 by 9 feet? Okay, your first step, get the numbers out of the words. And getting the numbers out of the words, each wall is 11 by 9, so each wall is 99 square feet. We've got 4 walls, so 99 times 4 is 396. We want to know how many 8s are in there. So 396 divided by 8 gives us 49.5. Okay, remember, if you've got half a gallon, you've got to have a whole gallon to have that half. So you've got to, in this case, round up. You've got to have 50 gallons. The SAT will also ask you for remainder problems. These are problems to determine if you know that there's actually a number left over when you divide one number into another, not just decimals. For a remainder problem, it's going to be to have you make your calculations using your calculator and see if you can determine that those decimals really mean a number. In this case, we're reducing the number of classes from 28 to 25 but keeping the same number of students. So we want to find out how many students we have in these 28 classes, each with 22 students. So we multiply 28 by 22, gives us 616 students. We now divide the 616 by 25, leaving us 24.64. That 0.64 is 0.64 or 64% of 25. That gives us a real number of 16. After in a more abstract fashion, as in this case where they say x when divided by 5 leaves a remainder of 2. What would be the remainder when 3x is divided by 5? Well, simply pick a number that fills the requirements. We want a number that leaves a remainder of 2 when divided by 5. 7, 12, 17, something like that. Let's pick the smaller one. 7 times 3 is 21. When you divide that by 5, it leaves a remainder of 1. You'll see sequences on the test. Two types of sequences. An arithmetic sequence simply follows a pattern where you're adding a number to each term before it. For instance, here we're looking for the 23rd term in the sequence 4, 7, 10, 3. Well, we can see from the sequence that you're simply adding 3 to each number before it. And you determine the nth term in that sequence by multiplying 3, because that's what you're adding to each term, by n minus 1. You use n minus 1 so that you don't count that first term. So this problem would be solved with the formula 4, the first term, plus 3, the unit that you're adding to each term, by 23 minus 1. You've got 23rd term you're looking for, and you've got to get rid of that first one. Therefore, you've got 4 plus 3 times 22, which is 4 plus 66, or 70. You can also encounter a sequence which involves geometric or exponential growth. Now, this is a sequence which involves a ratio between consecutive terms. You might find this in a population type problem, for instance, or one like this, where you have a sequence of 3, 12, 48, 192. What would be the value of the 8th term? Well, first we have to determine the ratio. 12 divided by 3 is 4. 48 divided by 12 is 4. 192 divided by 48 is 4. So our ratio is 4. Determine that our ratio is 4. We now apply that to the formula of 3, the first term in the sequence, times 4 to the n minus 1. Again, the n minus 1 eliminates that first term. That takes us then to 3 times 4 to the 8 minus 1, or 3 times 4 to the 7th, which is 3 times 16,384, which gives us a final value of 49,152. There are two types of variation problems that you'll see on the SAT. If numbers vary directly, they have a common factor. By that I mean if y equals kx, where k is a constant, and concomitantly y over x equals a k constant, then you can say that these two numbers vary directly. For instance, if y equals 4x, you then just follow it. If y is 8, x is 2. If y is 12, x is 3. If y is 32, x is 8. Numbers vary inversely if the product of the two variables is constant. For instance, x times y yields k, a constant. In this case, if you divide that constant by one of the variables, you'd get the other variable. For instance, y would equal k divided by x. Let's say the product of x and y is 30. Well, in that case, if you have y equal to 3, x would be 10. If y is 10, x would be 3. And if y is 6, x would be 5. And you divide the constant by one of the variables to find the other variable. You'll encounter a little bit of trigonometry on this test. But so far, from what we've seen, using the acronym SOHCAHTOA answers all of these questions. Now let's look at what this acronym means. You determine the side of an angle by dividing the line opposite the angle by the hypotenuse of that triangle, thus giving you the SOH, or SO. The cosine of an angle is determined by dividing the side adjacent to that angle by the hypotenuse of the triangle, thus giving you CAH, C-A-H. By dividing the side opposite the angle by the side adjacent to the angle, thus giving you the TOA or TOA. So this gives us SOHCAHTOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. SOHCAHTOA. Slope problems are really pretty easy if you remember that slope is just rise over run. The distance a line goes up divided by the distance the line goes across. So what we're talking about is the difference in the y coordinates divided by the distance in the x coordinates, or the change in y divided by the change in x. Let's look at an example. Let's say that there's a line that extends from the points 3, 2 to 5, 4. What would the slope of that be? Well, we simply look at the numbers. The y points are 2 and 4, so the difference would be 4 minus 2, or 2. The x coordinates are 5 and 3, so 5 minus 3 is 2. Therefore we have 2 divided by 2 and a slope of 1. Slope using the point slope formula. Y equals mx plus b. If you can get an equation in this form, y equals mx plus b, you can then use m as the slope. The horizontal line has a slope of 0. A line sloping down, left to right, has a negative slope. Also determine the slope using the point slope formula. Y equals mx plus b. If you can get an equation in this form, y equals mx plus b, you can then use m as the slope. You'll also encounter combination and permutation problems. Now, permutation is where the choice is affected by previous choices. Let's look at a permutation problem. You're asked to assign a number to 5 different desks. You can use any one of digits 1 through 9, but you can't repeat any of them. How many combinations are possible? Okay, you have 9 possible digits to use for the first desk. Since you've used that number, you can't repeat it. So you only have 8 numbers left for the second desk. Since you will have used 2 numbers now, you now have 7 choices. So to work it out, it's 9 times 8 times 7 times 6 times 5, which gives us 15,120 possibilities. With the combination problem, the previous choice has no impact on the outcome. It makes no difference in the outcome you're looking for. Also has been asked to determine the order for 5 bands to appear in the Battle of the Bands. And we want to see how many total combinations they have to choose from. Well, this is a completely random event. Since it's completely random, we can use the factorial mathematical operation. In this case, we have 5 bands. So it's a random order, and we can use the factorial of 5. So 5 factorial is 5 times 4 times 3 times 2 times 1. So we have 120 possibilities for these bands.